Okay, so uh, one of the ways that we can understand one-to-one functions is by looking at the graph of the function. Okay, and so what you can see here is this is the graph. Let's assume that this is the graph of a function f of x, and so we're going to say that this graph is the graph of f of x. Okay, and so we want to know is f of x one-to-one. And remember that our definition of one-to-one is if we select any output value, is there only one input value? And so here, this red line right here, this represents the output value y equals 2. And so we can say that f of x equals 2 when x is equal to what? Well, look what we have here. We can see that that this point right here is the point 1, 2. So when x is 1, then y is equal to 2. But look at this point right here. This is the point negative 1, 2. So also when x is equal to negative 1, the output is 2. And then this point right here is the point negative 3, 2. So there are actually 3x values. There are actually 3x values that result in having an output value of 2. And so f of x is definitely not one-to-one. Okay? And so what we did here is we used what's called the horizontal line test. That we can, if we draw a horizontal line anywhere on the graph, if that horizontal line crosses over the graph in more than just one place, then we know that that particular function, that graph, is not one-to-one. Okay? So we call it the horizontal line test. It's kind of like the vertical line test for a function. With a vertical line test, if the vertical line crosses over the function or the graph in more than one place, then it's not a function. So here, the horizontal line test is determining whether the function is one-to-one. Okay? So let's look at a couple other examples where the horizontal line test does pass. Okay, so what I've done here is I've put in this horizontal line that's moving up and down, and we can see if I were to put a graph on here whether this horizontal line is crossing over the graph in more than one place. Okay, so here is a linear function, and we can see that as we follow the horizontal line as it goes up and down, there is never a time that the horizontal line is crossing over this linear function in more than one place. It's only ever crossing over in more than one place. So this linear function is one-to-one. Okay, here's a quadratic function. It's a parabola, and you can see as this horizontal line moves up and down that in many places it's crossing over. In fact, if I freeze the line, you can see here that the horizontal line is crossing over the parabola at this point here, and it's also crossing over the parabola at this point here. So it's for the same y value, it has this x value over here and this value over here. So that's two x values for this one y value. And so this graph does not pass the horizontal line test, so this graph is not one-to-one. Okay, here's what's called a cubic function, and you can see that even in here, it only ever crosses over the graph in one place at a time. It travels up along, and then it goes over here, and then up here. So it never crosses over this cubic function more than one point at a time. Now there are some cubic functions. In fact, the example that we did a little bit earlier was a cubic function, the one that had 3 points of intersection. But this one in particular only has 1 point of intersection at any one time, and therefore this function is a one-to-one function. Okay, this is the graph of a trigonometric function called the sine function, so sine of x. And you can see very clearly, even without this horizontal orange line, even the x-axis passes through. This horizontal line passes through the graph repeatedly. So here's 1, 2, 3, 4, 5, 6, 7, 8. So there's lots and lots of intersections here with the horizontal line. So sine of x is not a one-to-one function. It has repeated input values for just one output value. Okay, this function is a square root function, and you can see that the horizontal line never passes over in more than one place. In fact, this is one where I'm going to stop it. So you can see if I stop this horizontal line from moving, we can see where it intersects this graph right here. And as we move from here to here to here to here, it's still only crossing over this graph at only 1 point at a time, and therefore the graph of this function is one-to-one. But now look at this absolute value function. You can see that the horizontal line almost always is crossing over at 2 different points at any one time, and therefore this absolute value function is not one-to-one. And lastly, let's look at this function right here. This is a rational function. You can see that the graph, if you can follow this, is only the horizontal line is intersecting this graph. It kind of jumps from over here over to here, but still never at one time is it ever intersecting this green graph in more than one place, and therefore this rational function is a one-to-one function. And so this is how we can use this horizontal line test to determine whether a function is one-to-one